NTU World of Wisdom. Welcome to High Impact Thesis. In this podcast, we speak with researchers from various scientific fields to talk about the motivation, goal, and potential impact of their research. We also want to give you a sense of how a PhD is carried out with an emphasis on the PH, the philosophical aspects involved in pursuing a PhD. Greetings, everybody. Welcome to another episode of the High Impact Thesis podcast. As many of you who listen to us may well be aware, on this podcast, we invite researchers from NTU across, as well as across Singapore, to talk to us about their research. So today we have Rajat with us, where he will talk to us about structural health monitoring. So Rajat, welcome to the High Impact Thesis podcast.
Yeah, thanks for having me here.
So Rajat, how about you tell us a little bit about you, the person, just a little overview of who you are, so that we familiarize ourselves with you, the person, before we get into what you do.
Yeah, so personally, I feel interested into developing devices, the wireless devices, where we can just put everything in a box and it can transmit data all over the world. So yeah, moreover, interested towards developing electronics, IoT devices, and all.
Mhm. So what is the very short description of the research that you're doing? This question is more generous in the field that you are a part of. What would that be described as, or what are the general questions that your field tries to answer?
Okay, so my research topic is here is structure health monitoring. So basically, its name also tells it like monitoring the health of a structure. So basically, if you to measure the strain is a physical quantity that is its formula is as delta L upon L, which signifies that how much a structure bend from its normal length. So it is something very important because if you are able to monitor this, then you can actually make sure that within how many days or what's the situation that the structure will break down. So to monitor this, we are working towards this sensor optical. We try to monitor this strain of the structures via optical sensors and electrical sensors. So yeah, and actually it's a very natural phenomena which we don't observe, but the buildings which are very high, this sways maybe let's say for 2-3 centimeter or something, but we are not able to observe it. But if they are swaying and beyond a particular number or something, then it might be a bit dangerous. So if we are able to monitor it in real time, then okay, then we can make sure that nothing dangerous can happen.
Thanks very much for that intro about structural health monitoring. I'm assuming this applies to a lot of areas, not just buildings. It could be railways. It could be, it could be other structures. Is my assumption correct?
Yeah, it's not only buildings. It's related to civil. So it can be, you can monitor the ground settlement, like how soil is moving below the ground, or you can monitor. Basically, it's all about how you want to monitor the change in the length. The change in length can be of any building, or maybe it can be of railways, or it can be of the soil and all. For example, for soil, if a building is made, you have to make it foundation first. So you will want to make sure that the foundation in which the soil is there, it does not just move down with water. So for that also, you will want to make sure that you will want to monitor it. You will here we deploy some sensors, and the device that we had made for that is known as inclinometer. So again, it's a bit detailed matter, but yeah. So it's not only the buildings, but any civil structure you can monitor.
I have a question about application of these kinds of sensor technologies on civil structures like buildings and bridges and others. So are they more focused on observing the long, like if you have a building, maybe after 2 or 3 years, We'd like to know if there is any structural damage or something is happening that's causing the building to sway one way or another. Would that be, for example?
Let's take an example of bridge, not building. Then you will be able to imagine better. So I think there in some year in Singapore also there was a bridge that collapsed. So it's not only buildings, and so with time, not only for a few days of construction only, after few years it will be like continuously required to be monitored.
I was also wondering, I don't know if this is true or not, but do you think maybe the wind in some cases might cause the building to move or sway slightly one way or
Yeah, actually right now also the parking buildings, not only parking buildings, they actually sways, but it's not observable from our eyes. This sways. Even I think the N1 building on which I am, in which I am sitting, I think that also must be swaying if the wind is there. You can find few YouTube videos also or something in which you will be able to see if some bridges like flowing like this.
Yeah.
Then also they are flowing like this or moving like this. Yeah.
Because I mean, there was I think sometime earlier this year where there was a building in China that was visibly floating back.
Yeah.
So it's okay. It's like it should be within a limit. We cannot stop it to move, but it should be within a limit. That's why this is a research topic. Structure health monitoring.
I'm saying so. I think that what was still, or at least moving on from the more general, I was just wondering was this field born after you have these tall buildings? How far back are we looking at in terms of this as a field, as a serious field? Because I assume 2,000 years ago, it probably didn't have structural health monitoring. They didn't really have the sensors, the ability to sense the strain that a building has undergone. Is it after we invented or started building tall buildings that this became a serious area of research, or what triggered it?
So you're asking like when structure health monitoring started or what triggered it?
Yeah, not exactly the date, more like the events that precipitated this to be something that
I think
looking into.
I think there was a major event in Singapore. If I will talk about Singapore, there was a bridge collapsed, and they found out that because of the current health monitoring, the way they were actually monitoring the structure, it was not correct, and there was some anomaly in that, and that's why they moved to the optical sensors and all. But if you will talk about that when structural health monitoring started, I also never tried to find out this.
Yeah, no problem. I think the reason I was actually asking the question was just, in the past, if you did not have any means of determining how
actually, then I think the possibility of a collapse of a civil structure must be more at that moment. Even now also the structures collapse. If you remember in US just this year only, one building just collapsed. Even we are talk about AI and all machine and all these things, still that collapsed. So few years ago, at that moment, possibility must be much more of the collapse of a structure. But now you can try to make sure that that it doesn't happen, but still there is a little bit of possibility. So you can just decrease the possibility.
Yeah. That's true. Yeah, and I also think that to some degree, it if you don't have concrete knowledge of how the structure will evolve health-wise, I think you might want to overbuild, right? Just to really build so that it never falls, and maybe that might be wasteful. So in my head, I feel that this structure monitoring means that you somehow have confidence that we didn't just throw a lot of metal at it so that it doesn't fall apart. It's like you did the math, and then you are able to monitor, and hopefully that might actually reduce the overbuilding that probably.
I think you are asking like first, try to find the strength of the material that you are going to use by testing it and making sure that it's not bending under particular circumstances or realistic circumstances.
Maybe we can delve more deeply into your work now, because the first part was really just general structural health monitoring. Then maybe we can now delve a little deeply into what you actually do.
Yeah, so I think this gives us a good introduction about the structural health monitoring field in general and what's its main objectives. So now maybe we can dive into your own research focus recently. What are the main aims and objectives that you are working on at the moment with regard to structural health monitoring and developing technologies that might aid or help in this kind of work. So if you can share with us some of that, what's the main things you are focusing on recently?
Okay, so recently I have a patent filed. So it's an integrated device for electrical and optical sensing. So the conversation that we had in that we just discussed that we have to do how means what are the objectives of structure health monitoring, but how we do that, it's by the either by the optical sensor or by the electrical sensor.
Mhm.
So it's both are usually known as strain gauge, and if you are using the optical sensors, then it is known as kind of optical strain gauge. Otherwise, is a electrical strain gauge. So usually, right now in market, people are using that optical sensor in a optical mode. But my part is to figure out a way to use it in a in intensity mode. Yeah. So first is this thing, and the reason because of this is if you want to use the or to find out the strain using optical sensors in optical mode, then the device to do the monitoring in that way is a bit expensive. But if you will do it in intensity mode, its price goes dramatically down. So my part was that, but the patent that I had filed is in that device. I have figured out few architectures so that we can find out the strain in intensity mode, and also we can use electrical sensors to find out the strain. So it's an integrated device. So having a capability that we are actually attach our electrical sensors. Also, the advantage is that electrical sensor is very cheap. It's like I think just $5 or $6 you can get an electrical sensor. But optical sensor it's a bit expensive. Both are having their own pros and cons. So if you are having a device which can with which you can attach both, these are advantageous. So let's say if you want to deploy the device at a place where you want to attach or measure strain of many positions, but uh, on one position you want to measure position for a long time, then you can attach optical sensor on that position, and all other position where just want the strain for few days, you can just attach electrical sensor.
Mhm.
So yeah, and both are having their own pros and cons. First is that I told about the cost. Optical sensor is a bit expensive, and that is very inexpensive. And advantage of having optical sensor is like you can its life, it doesn't spoil easily in wind with water and all. You can use it in underground or with water, but what that is electrical, it is made up of copper actually. So
Mhm.
yeah, so it's a resistor actually. It's a simple resistor, and we are using it to measure the strain. So it can get rust or its life is not so well. And also because it's electrical sensor, it's affected by electrical signals. It can, yeah, but optical sensor is not affected by that
I see. I see.
due to interference. Yeah. So yeah, so this was the device.
And how about you said something about the using intensity mode, right?
Yeah.
Yeah. So if you can clarify what's in intensity mode, in which
Okay.
is it
Okay.
used? Oh,
So for that, we have to understand the way that optical sensor works. So
yeah.
actually, it's not optical sensor. Its name is FBG, fiber Bragg grating.
Mhm.
Sorry.
FBG, fiber Bragg grating.
Hmm.
Okay.
Yeah. Yeah. So how it works is from the LED source, we first send a band of light.
Mhm.
Okay. Just imagine, a parabola is like this. Then y equals to x square, if I'm not wrong. Yeah. And y equals to minus x square is like this. So you have a band of intensity, let's say from 3000 to 1400 nanometer.
Mhm.
Then you have an intensity of light. So when you are sending this intensity from the fiber, so when the moment it will come towards the FPG, the grating or the sensor, so the sensor will reflect a little bit band of the light. Let's say you have sent 3000 to 1400 nanometer, the FVG will reflect LECT from let's say 1350 to 1360. and the band of light which is not reflected will be transmitted. So now the catch is the way the FBG band of light which is reflected shifts here or there.
I see. I
Got
see.
it?
I see.
So if FBG will band it, if let's say FBG will bend like this, or there will be a tensile strain, or tensile strain, then the band of light will shift right.
Mhm.
Okay? So and when it will compress, then the band of light will shift left. Okay. Now if you have a device which can detect that what is the wavelength of light that is getting reflected, from that you can say that okay, this much should be the strain.
Mhm.
Okay. Now there are many devices in market which try to find out that what is the wavelength that is reaching at their point, so that they can find out the strain. Or
I see.
maybe if you know the wavelength, then you can calculate that what should be the strain. But they are not focusing on the intensity. Intensity means we are actually sending a band of light, but it is having some intensity. So
Yes.
so if you will talk ideally, then it should be a rectangle kind of thing, like 1300 to 400. And if you will say like 2 nanometer, then if you will be able to imagine the graph, it would be a rectangle. But usually it's like a reversed parabola. So in my case, it's the architecture of the sensor is like that if you will provide a tensile strain, then the intensity of the light that will be reflected, it will increase in a linear fashion with respect to strain. And if you will provide a compressive strain, then the intensity of the light will decrease in a linear fashion.
I
So,
see.
so when you are working in that mode, then the price of or the electronics that you want to use, it decreases drastically.
Because
I
you use
see.
a smaller band, or
Actually, it's not because of band. It's because the electronic circuitry that we need to change in intensity of light, it's much cheaper than to find out that what is the wavelength that is coming right now.
Mm,
If I
okay.
want to detect that what is the wavelength of light,
Mm,
it's expensive to make the device. If I want to detect that what is the intensity of light,
I see. I see.
then it's and
Ah,
it's kind of very simple. Just if you can use a diode, and because the photons number of photons is intensity of light, and the number of photons is proportional to the bond breaking or the number of electrons and holes in the diode. So you
Mm.
from that you can figure out that okay, this much current means this much of intensity.
In a way, it's
I see.
like operating a solar cell in reverse, right? Or
Yeah.
not really in reverse, but it's more like a solar cell.
Yeah, solar cell also uses diode if I'm not wrong.
Yeah.
Yeah, but solar cell is like at very high intensity, but here we are uh, talking about source. The source that I have is in microwatts, and when I pass it from an FBG, it becomes in nanowatt. For
Mhm.
particular kind of FBG, but I think for solar cell, it's in what order? Watts if we talk about?
I think it depends on the size. Like I work with some solar cells that
Solar cells usually
the
in the milliwatt range, like 100 milliwatt per centimeter square,
No,
something
no,
like
we
that.
don't. Right now, I my one the LED source was only microwatt or something.
Yeah.
Mm,
Yeah. So if I understood correctly, so the idea is that the optical mode, there are two, sorry, the optical sensor, there are two modes. One that uses the change in the wavelength to detect the tensile
Yeah,
strains on the,
yeah,
and the second one is using the intensity, the change in the
yeah,
intensity.
yeah, yeah. And the optical one is quite extensively used. It's
Mhm. Mhm.
extensively used. Yeah,
I see. And so of course, the also the detecting the changes in the intensity is much cheaper compared to the circuitry and the components you need to detect the
yeah, yeah,
changes in wavelength, right?
yeah, yeah.
Okay, see, interesting.
And then it's about if you are able to send the signals or transmit the signals to the user wirelessly, than in countries like US, Europe, and Singapore. It's also a very nice addition, or yeah, advantageous, because here manpower is not cheap.
Yeah.
So yeah, so the device that we are trying to make is also, this is also KPI. How to say, it's a USP. You can say that it's wireless also.
Yeah, I actually wanted to get a sense of the actual deployment of such a device. So when you talk to us about a sensor, is it as like it measures voltage and does a little bit of computer stuff and talks to a sensor,
Yeah.
talks to a microcontroller away from it, or is it like it just gives you a voltage and then you do the interpretation somewhere else? Like, is the sensor
Oh,
itself
you
with
are
the
you talking
microcontroller?
about that how we deploy it at ground, or are you?
Yes, when you say that I give you a sensor to someone, do they get back, digital information from the sensor, or is it the voltage itself that they have to process, like for your sensor? Does it have a microcontroller?
Actually, it's up to the vendor how he want. Obviously, if a vendor want to give a service, he will not give him voltage. He will use the DSP and all, and the programming and all, to convert that voltage into something meaningful, so
Mhm.
that the guy can understand that, okay, this means that whether, because the user don't know any maths or all, he just want to know whether his building is okay and or not.
Mhm.
So all these things should be done within the device, or maybe on cloud or something.
So it means that if I have a building that I want to monitor, the building has already been built, and I'd
Mhm.
like to monitor it. Does it work, or does it only work if I tell you before I build the building so that you put your sensors up as they are building? What is the actual way to deploy these sensors?
So far, the sensors that we had deployed, they are only deployed when the buildings were constructed. So we have deployed the sensors in few HDBs,
Mm-hmm.
and and there was a mall that was building near to Thompson Plaza here. So yeah, so it was regarding the ground settlement monitoring. So we are trying to test bed our inclinometer, so to see that how soil is moving with our sensor. So on one side, the contractor were having their traditional sensors, and on another side, we deployed ours. We found that the results were same. So far we have just did when the construction is going on, but if we, I think it should have this application also. I think for bridges, let's say, everybody will like to monitor it continuously at the governments and all, because there are bridges I have heard seen in news, like after a few years, that it collapsed, or the buildings it collapsed, and it's about the concern of the owner of or the government, or the authorities, that whether they want to make sure that the thing is okay or not. So, and also with time actually, if something is good in the starting, that does not give you a guarantee that it will be always okay, right? So I think it should be used later on also. Yeah, but so far we have deployed only for or test bed our sensors and technology during the construction phase only. Actually, I'm working with Prof like 3 years or something. So whenever he asked me, so it was just for the construction phase. So maybe if he's here since 20 years, I will ask this question whether he had do something for that phase or not.
Yeah, so I had a question about, yeah, I forgot to ask you on this. How does the electrical sensor or the electrical way of doing the sensing, if you can share with us, how does that work exactly? Is it simple resistor or what?
Yeah, it's simple resistor, but the way we are using it, that is something which makes a difference. So in your school days, maybe you may have heard this formula: R is equal to rho L upon A. That is, resistance is equal to resistivity multiplied by the length of the wire divided by the area of cross section of the wire.
Yeah.
Right. So if you will make area of cross section as constant, and you are not changing the material, that means your resistivity is also constant. That means the resistance of the wire is proportional to the length of the conductor. So so the strain gauge, so that sensor is actually, what is happening is, with when the strain is provided, it's the length of the conductor changes. And because the length is changing, the resistance of that conductor will also change. So if you are able to monitor the change in resistance, then you will have a formula with resistance. This much is the strain. You can figure out a formula with the data or the experiments. But the thing is, change in resistance is not easy to figure out. So what we usually do is to use a Wheatstone bridge. If you I think you are from Tripoli, you must have heard about it. Wheatstone bridge. Yeah. So Wheatstone bridge, what it do is, it gives us a relation between the change in resistance of a resistor and the potential difference from 2 points of that bridge. So from that, we are able to directly relate the change in voltage to the strain or the change in the length of the conductor. So you're getting right.
Yeah.
So when you will stick that strain gauge over a material, right? Then when the way that material will move, you will be able to get the change in voltage.
I see.
Yeah. Yeah. So then once you have a formula to convert that voltage into that strain, then actually you can generate some insights for the user.
And how about the resolution for the electrical versus the optical methods? Like, how high is the resolution for the you know
Okay.
the sensitivity of the
Yeah.
method?
If I will talk about accuracy, so optical device, the accuracy, the devices that in the market they claim to have around 10 microstrain or something. But for our device also, we are able to achieve 12 or 13 microstrain. You can say 10 microstrain. But this is something which is right now we are working on. If we are able to increase the power of our source, which is coming in like microwatts or something, and we are, I think, almost over there, because we are able to find a vendor who can provide this kind of LED. So I think we will be able to achieve much better than that as well. Yeah. So for optical sensor is 10 microstrain, and this electrical sensor about which I'm talking about is the device that I have made. But I think in market also it's there, that is also in few microstrain. I think in 20 right now I was able to get the same kind of 15 or something microstrain. I think in market also something, it's usually near to just 10 microstrain or something. But yeah, if we can work over on this device, then we can get to few microstrains as well.
I see. All right.
Thanks very much for talking to us specifically about what you've done, Rajat. And in this third segment of our episode, usually we try to talk very broadly about your field, but more you as a person, how you envision your field growing. And so, if your device or the device that you're building or the device that you want to build, if it were deployed in a large scale, what kind of impact do you see it having on society? In other words, your research done 10 times more or 100 times more. Where do you see this? What kind of contribution do you envision?
I think if in one word, it's safety. You can feel safe, much more safe.
Okay. And currently, what do you think are the major, I guess, roadblocks or the major hurdles that your field or your device needs to clear in order for it to gain acceptance? Because I know that the construction industry is one of those that is not very welcoming to, I guess, new technologies, since they have been doing things a certain way for a long time. So I'm just wondering, what would it take for your device to gain acceptance on a large scale projects?
If somebody is able to save money, every today or tomorrow they will be, accepting it. So kind of USP of this device is that it's kind of very much cost effective, and the hurdles that you are just asked, there are few tests that I did. I just found out that with temperature, the output signal is changing. So during the test bedding, we found out this that it was working fine in the lab, but when we deploy it in the buildings to find the strain, so the buildings were in construction phase. There were no windows or something. So the sunlight was coming during the afternoon time in 11 to 1 or something. So we saw like signals are going like this, like there is a disruption or something happened. So later when we investigated that, then we realized it is because of the temperature only. So these are things that I see it's kind of challenge.
I think also it just came to my mind that maybe the variation in temperature during the seasons might influence or do you think it's not a big factor?
No, it's not a big factor. Conceptually, it's not an issue. It's just the compensation that we have to do.
I see. Okay.
Yeah, so we can actually, the architecture that I have, the FBG, the problem with FBG is also this. So FBG is not only affected by the strain, it is affected by temperature also. So it will shift with temperature as well. But the vendor who is deploying it, he will compensate it. How that? First, he will stick that amount, that FBG over a place where he want to measure strain. So that FBG will show you the value of strain plus temperature change. Then you will have another idle as FBG, which will just move with temperature. Then you can compensate both of them.
Yeah, makes sense because you can easily just get rid of the effect of the temperature on the measurement.
Yeah, and actually it's not an issue with this device only. It's the issue with many devices. So mostly they do the same thing.
All right.
So at this point, we're kind of moving away from very specific research things. So if you think there is something you just want to highlight to the audience, something that excites you about this research, something we've not really touched on that is very research specific, would like to give you a chance to say that. Because I actually didn't know much about it, so I've learned quite a bit, but there might still be some interesting things that we don't know as people outside the field.
I want to change my field. The question that you ask is that something, what is the thing that drives me as a person? So I feel more about if I can impact over the environment.
Mm-hmm.
So that's why I'm looking in a field of predictive maintenance and conditional monitoring. This is also kind of conditional monitoring, but I want to move into that field where I can actually save the electricity and indirectly affect or decrease the power consumption.
I see.
But it is actually, you can say, completely different from this field. So it's moreover about three-phase motors and the equipments that are used in industries. Like if you want to use a compressor, you need an induction motor to run it. Yeah. So the thing is, if you are able to maintain it, then right now the way the maintenance is done is in a regular based manner. So if you are able to do it in a need-based manner means like if you realize that okay, now it needs some maintenance, not every time, right? Then you can save the manpower or the money because of the manpower. And also the thing is, when the device is working and you are letting it working all the time, right, without doing its service, then its power consumption increase with time. Yeah, so if you are able to provide it service at a particular time, then you can actually control the power consumption also. So it's not a field in which I have get into too much deep, but there's something I feel a bit interesting. So whenever I just search about the three-phase motor, I just saw like if its efficiency is getting decreased, then its signatures changes, its vibration signature will change, its electrical signature will change it. Yeah, then its and its ultrasound signature will change, and then slowly it will start making noise and smoke and all. So if we are so first signature that changes is the ultrasound signature. If we are able to just note it from at that moment only, that okay, now it needs service, then we can do its service at that moment. Then it will not get it to the moment that we are able to diagnose the problem from noise and all. So we can save that power. So basically, making the efficient, if we can make the industry efficient, then I think we can save the power and electricity. And if we can actually save electricity, then I think we can save the carbon emissions as well. Yeah. So yeah, I want to change my field. So
Okay.
yeah.
All right. So as we approach the end of this episode, would always like to steer away a bit from the research talk and all of that, and to get to know you at a more personal level. So perhaps we can ask you to share with us some of the interests or hobbies or activities or etc. All things you like to do in your free time outside your research interest. So if you can share with us some of those.
So I like to play guitar, and I try to write things. If you will ask about hobbies, yeah, these two things.
So self-taught or how? Like, did you get lessons initially or
Yeah, I actually just watch YouTube videos.
yeah? I think YouTube makes everything
Yeah,
quite easy. Yeah,
it's kind of revolutionary actually. Yeah.
yeah.
Actually, I wanted to ask specifically about, you said you have a patent, and could you share maybe with our audience who are researchers and they're intending to do a patent of sorts?
Mhm.
Any lessons learned? Any advice for folks who are interested in patenting their ideas?
It should have a novelty, I will say that, and try to make sure that the direction that in which you are working, the supervisor helps in that thing, that whatever the direction that you are choosing or giving the efforts, it should not be wasted later on. So make sure that it is having a novelty that you will get the patent. If you are actually focusing to get the patent, then it's very obvious. But it has happened with me actually. My prof asked me many questions, that how it's something novel, how you are saying it's something novel, it's how it's patentable, they will just reject it. So yeah. And also it's better to have a partner. I will not say better, I will say always have a partner who is RF or somebody who can actually guide you. Even a small advice can save your 3, 3, 4 months.
Mhm.
So it's good to have a partner. Just don't think that he will take the inventive contribution or all these things. Yeah, and I think you're just one question that you were asking, like if you want to share. It's another thing about my work. It's not regarding this structural health monitoring. It's that project I didn't share too much because it's not about research. There, my part is moreover about the project management. So it's the project granted by HDB. HDB, right, Housing Development Board. It's funding. It's a agency under MND, Ministry of National Development. So it's I'm project manager there. My key deliverables, or basically I report to my boss regarding that project only. So that project is regarding tracking of the precast component. Till now, whatever I talked with you guys, it was moreover about measuring the strain. Here it's about tracking the precast component. So precast component.
These are concrete components that
Yeah,
are taken
yeah,
to the
yeah.
construction site and
Yes, yes,
placed.
yes, yes, yes. Yeah. So instead of taking the bricks and putting one by one, making a wall at the construction site only, it doesn't happen like that here. What they here the fashion is like, they will make the whole room, let's say bathroom, or the whole PPVC or that component in Malaysia, usually Malaysia, and then they will transfer it to Singapore. Then you may have played Lego, or maybe you have
Lego. Yeah, yeah, yeah.
Lego.
Yeah.
So it's the same way. So then they will just pick it up from the crane and they will drop it there. So this project was about, keeping a track of this, that where is the precast component right now, it does arrived to the construction site or not, at what place is it, using RFID. So using RFID tags and RFID handheld and all. So technical part we have outsourced it, and actually mostly we have outsourced it, and we are just managing and making sure we are towards the deliverables. Yeah.
Great. Thanks for
Yeah.
sharing that. So Rajat, we appreciate your time here and talking to us about structural health monitoring. I think it's an interesting field, and that's something that, even though you are shifting away, I think something that we hope you have learned lessons as well that we'll apply to whichever other field you're going into. I mean, in general, our episode is supposed to highlight the things that can be applied not just in your specific field, but in other fields as well for our listeners. And we think that, for example, the ideas you've shared about patenting, these are ideas that apply broadly across many fields. So we appreciate you sharing advice on that. So thank you for being with us today, Rajat.
Thank you very much.
Thank you.